Alright, so I'm doing problem 13.33. Another eigenvalue question. Is this function blank, that's e to the negative ay squared over 2, is it an eigenfunction of the operator ddy squared minus a squared y squared? And if so, what's the eigenvalue? Okay, so another problem like we've had before. Alright, so what I'm going to do when I get something like this, of course, I'm going to write it out in some form that's familiar to me. I can write it, here's my f. Now it's not f of x anymore. Oddly, that sort of does make it a little more difficult because we're used to dealing with x. But of course, it's in principle exactly the same thing. And here's my operator. Okay, so this appears to be a linear operator. What I'm going to do is do these two operations separately. And the first one I'm going to do is dy f of y. Okay. I'm going to let u equal ay squared, or minus ay squared over 2. So d du dy is going to be equal to minus 2ay over 2. Okay. And df of u dy is equal to, well, let's see, f of u, just a second here. F of u is equal to e to the u, because I chose that, right? So df du, sorry about that, that's a mistake, is equal to e to the u, right? So df dy is equal to df du du dy. Chain rule, old friend of ours. So df du is equal to e to the u. Du dy is over here. Minus 2ay over 2. So it looks like it's simply minus ay over 2. Or rather, sorry, over 1, because these two's canceled. E to the minus ay squared over 2. Alright, that's df dy. Now the second derivative is I'm going to have to use the product rule. I'm going to let this be g. Let this be h. G squared is going to equal g prime h plus gh prime. G is equal to minus ay. H is equal to e to the minus ay squared over 2. G prime is going to equal to, this is prime with this is derivative with respect to y. It's going to be minus a. And h prime is going to be, oops, looks like I just did that, right? I just did the derivative of that. So it's going to be this whole thing is going to be h prime. Minus ay e to the minus ay squared over 2. Okay? So this then, d squared f dy squared is going to be g prime, that's minus a, times h, which is e to the minus ay squared over 2, plus g, which is minus ay, h prime, which is minus ay e to the minus ay squared over 2. This looks like a pretty similar problem to 13 point, what was the one? 12a, I think. Okay. Still not done here. This is sort of a mess still. So I'm going to bring it up here. So I'm running out of space down there, and I'm going to say this is minus a e minus ay. Is ay squared? Oh, I got a problem. Wait, maybe I don't. I'm not sure if I lost that 2 somewhere. Okay, I counted for the exponent of the 2, so I'm getting nervous. I had forgotten there was a 2 there. But it looks like I accounted for that exponent here, so that's good. I didn't lose it here. Okay, so that's good. Oh, I didn't lose it. Okay, all right. It's all there. Got nervous though when I saw that 2. Okay, plus a squared y squared e to the minus a y squared over 2. So that's just the first half of this operator. That's just that part right there. So I'm going to do this. I'm going to say 1. 1. See what I did there? Now let's do the second part. A squared y squared. All right. A squared y squared. The function again is that e to the minus ay squared over 2. That's pretty simple. That's equal to a squared y squared. It's just a multiplication problem. E to the minus ay squared over 2. Now it's a subtraction, so maybe this is good news. Maybe it is going to end up being an eigenfunction. Okay? So that's part 2. Okay? So this operator is really part 1 minus part 2. Okay? So I've got part 1 here and part 2 there. You know what? Instead of rewriting this all out, there's part 1 and here's part 2, and it's all additive, right? It's minus here, plus that, and minus that, because it's minus part 2. Right? So that appears to be the same term. So it looks like if I subtract that from that, I'm just going to get a e to the minus ay squared over 2. Wow. Boom. Boom, boom, boom. So that was my original function, f of y. And so therefore, and that's a constant, therefore, this is my eigenvalue. Okay, that was easier than I expected. So yes, is an eigenfunction of the operator. Boom. And I think we're going to soon develop a new habit where we do a smiley face. Each time we get that, it is good news. Ears, a little bit of hair up there, and a nose. Okay, hopefully that's helpful. 13.33.